Hey everyone! Have you ever wondered what really separates a small, simple app from a global giant like Netflix or Amazon? I mean, what's the secret sauce? Well, it's not just about writing clever code. It's the architectural blueprint that everything is built on. Today, we're going to pull back the curtain and decode the core concepts of system design for the web.
So here's our game plan. First, we'll lay the groundwork with the system design blueprint itself. Then, we'll dive right into the biggest decision you can make, choosing between a monolith and microservices. After that, we get to the really cool stuff. How do you handle a massive flood of users? Where does all the data live? And finally, how do you make sure the whole thing is secure and never, ever goes down?
All right, first up, the blueprint. This is where the magic happens, way before a single line of code gets written. Think of this as the master plan. Getting this right is what separates a system that can grow into a titan from one that's doomed to fail.
And really, that entire plan boils down to this one single critical question. How on earth does a simple app scale up to serve millions or even tens of millions of users without just completely falling apart? The secret, as you're about to see, is all in the design.
So what even is system design? You know, the best way to think about it is like the architectural drawings for a massive skyscraper. It's not about what color you're painting the lobby. It's about the deep foundation, the steel frame, the elevator shafts. It's all the core decisions that make sure the whole building can handle immense pressure and stay standing.
And why do we obsess over this? Because when you get the design right, you can handle those crazy viral traffic spikes. You can protect your users' data. You can keep evolving your product without hitting a dead end. But if you get it wrong, well, you're looking at a technical nightmare that costs a fortune to fix.
Okay, with that blueprint in mind, we hit our first huge fork in the road. This is the foundational choice, the one that's going to define how your system is built and how it grows for years to come.
And you've basically got two paths you can take. On one side, you have the monolith. This is a single, big, unified application where everything, the user interface, the business logic, the payments, it all lives in one giant codebase. On the other side, you have microservices, where you break the application up into all these tiny, independent services that just talk to each other.
This table really lays out the classic trade-off perfectly. You'll notice monoliths are all about speed of development. They're simple, they're in one place. Perfect if you're a startup and you needed to launch your product like yesterday. But check out the disadvantages. A single bug can literally take down the entire application. Microservices, though, they are built for resilience and massive scale. One service can go down and the rest of the platform keeps on ticking. For huge e-commerce sites or big SaaS companies, that's absolutely non-negotiable.
Okay, so you've picked your architecture. You launch, and suddenly, you're a hit, a massive success. Now, you've got every developer's favorite problem: how to handle the challenge of massive, massive scale. To handle more users, you really have two main options. You can scale vertically, which is like upgrading your one server into a ridiculously powerful supercomputer. But there's always a limit to how big you can make it, and it gets crazy expensive. The smarter, more modern way is horizontal scaling. You just add more and more standard servers to the system. It's basically infinitely flexible, and it's the whole foundation of cloud computing.
But wait, once you have this whole fleet of servers, how do you direct all the incoming traffic? Well, you hire a traffic cop. And that is exactly what a load balancer is. It stands right at the main digital intersection, sees every single request coming in, and expertly directs it to the server that has the most free space, preventing any kind of digital traffic jam. And the process itself is just beautiful in its simplicity. A request from a user comes in. The load balancer does a super quick health check on all its servers, and then it just forwards the request to the healthiest, least busy option. This tiny, split-second decision is what keeps your favorite websites online during huge events like Black Friday or right after a Super Bowl commercial.
But what about making your site fast for a global audience? I mean, someone in Tokyo shouldn't have to wait for a server in New York. That's where a CDN, a content delivery network, comes into play. It's basically a network of servers spread all across the globe that store copies of your images and videos so it can deliver them from a location that's physically close to the user.
And the payoff here is just massive. By serving that content from a server that's just a few miles away from the user, you completely slash the loading time, we call that latency, which makes your site feel instantaneous. Plus, you take tons of traffic off your main servers, which saves you a fortune in bandwidth costs. It is an absolute win-win for speed and for your budget.
Now, the final piece of the performance puzzle is something called caching. The easiest way to think about this is like a high-speed, short-term memory for your application. By storing the data that gets accessed all the time in this temporary cache, the system doesn't have to do a slow database lookup every single time. It makes everything feel incredibly snappy.
So our system is now super fast and it can handle tons of traffic. But all that speed is totally useless without the data that actually powers the whole thing. And that brings us to the real heart of the system, the data, the storage, and the communication layer that ties it all together. Right at the center of pretty much any application is a database. And, you guessed it, there's a major choice to make here too. SQL databases are highly structured, kind of like a set of interconnected spreadsheets. They're perfect for things like banking systems, where the integrity of every transaction is absolutely critical. No SQL databases, on the other hand, are flexible, unstructured, and built to scale out horizontally, which makes them perfect for things like social media feeds or data from millions of IoT devices.
Now, in that microservices world we talked about, all those little services need to talk to each other. A message queue acts kind of like a postal service between them. One service can drop off a message, say, send a welcome email to this new user, and another service can pick it up and process it whenever it's ready. The key is, they don't have to be available at the exact same moment.
And what you're really seeing here is the power of working asynchronously. By decoupling tasks like sending emails or processing a new order, the system doesn't have to make the user wait. It can respond instantly, while all those background jobs are handled patiently in the queue. This is a total game changer for making a system feel responsive and resilient.
And to manage all of the traffic that's pouring into this complex system of microservices, you really need a front door. Or maybe like a bouncer. That's the API gateway. It's a single, secure entry point that handles all the important stuff, like authentication, checking for malicious traffic, and then routing each request to the correct internal service.
And for our final section, we need to fortify this system we've built. Because, let's be honest, a fast, scalable application is completely useless if it's insecure or if it's constantly offline.
You know, modern security isn't about building one big wall, it's about having defense in depth. And you can see all the layers right here. A firewall might be the outer perimeter, but encryption protects the data even if that wall gets breached. Strong authentication acts like an ID check at every single internal door. Each layer basically assumes that another one might fail, and that's how you create a truly robust defense.
And finally, we have reliability. The whole philosophy here is simple. You have to expect things to break. Great systems are actually designed for failure. If one database goes down, traffic is automatically rerouted to a backup copy in another city. If a server crashes, another one instantly spins up to take its place. The ultimate goal is for the system to heal itself before a user ever even notices there was a problem.
So there you have it. We've gone from a simple blueprint all the way to a fortified, global-scale system. We've seen how every single piece, from the load balancer to the database choice, acts as a critical gear in this incredible machine. Which leaves me with one final question for you. Now that you've seen the whole blueprint, if you could only pick one of these components, which one do you think is the absolute most indispensable heart of a modern web system? Thanks for joining me.